Welcome students. In this video, let us look at what a conic section is. Conic section. As the name suggests, conic section is the cross section that we obtain. Conic section is the cross section that we obtain when a plane cuts a double nabbed cone. When a plane cuts a double nabbed right circular cone. For example, so let us take a right circular cone which is double nabbed. Double nabbed means you have a cone on this side as well as this side. This is called one nap of this cone. This is called the second nap. So combinedly, this is a double napped cone. So imagine a double napped cone. You have to imagine in 3D. So you have a double napped cone whose semi-vertical angle is alpha. Semi-vertical angle. That is half of the angle that is formed here is represented by alpha. So let us take that semi-vertical angle is alpha. Now you take a plane and just cut this cone. So the cross section which you get is called a conic section. And depending on the position of the plane, depending on the position of plane, you get different types of cross sections. For example, if the plane cuts this cone exactly perpendicular to the axis, so this is the axis of the cone, and if the plane cuts exactly perpendicular to the axis, you can very clearly see that the cross section will be a circle, right? So circle is one of the conic section. Next, instead of a horizontal line, let us take a plane which is slightly inclined to the axis. So this plane is inclined at an angle of 90 degrees to the axis. If you take this as theta. So this line represents a plane. That is a plane which is exactly making 90 degrees with the axis. If the plane makes 90 degrees with the axis, obviously the cross section will be a circle, right? And now if the plane makes an angle somewhat less than 90 degrees, if this angle is somewhere in between 90, somewhere less than 90 degrees, then this plane cuts a cross section which looks like an ellipse, right? So if the angle is 90 degrees, then you get a nice circular cross section. If the angle is less than 90 degrees, you won't get a circular cross section, you get an elliptical cross section. You get a cross section which is like this. So this is also an example of a conic section. So this plane meets the cone completely. That is, you get a closed figure. You get a closed figure like this. But once the plane's inclination increases such that this plane becomes parallel to this line. So you have an angle of the cone. If the plane makes the same angle alpha with the axis, if the plane makes the same angle alpha with the axis as the corners of the cone, you can see that this plane cuts the cross section which is open, because this plane will never cut this corner of the cone. So you get an open cross section which we call it as a parabola. So as long as the angle is between 90 and this angle alpha, you get a closed cross section which is usually called an ellipse. Exactly when the angle is equal to alpha, you get an open cross section which we call a parabola. and if theta is less than alpha, so if the cross section of the plane still increases, you can see that this plane cuts the double nap once on this side and another time on this side also. You get two cross sections. You get a cross section somewhere here and a cross section somewhere here. You get two open cross sections, which is called hyperbola. So depending on the position of the plane, you get different cross sections, which are all examples of, all of these are examples of conics or conic sections. There is another case called degenerate conics. Degenerate conics are the conics which you get when the plane passes through the vertex of the cone. So if the plane passes through the vertex, then whatever sections you get are called the degenerate conics. So if the plane is cutting perpendicularly to the axis, you get a point. Point is a degenerate conic. And if the angle, as long as the angle is between 90 and alpha, you go on getting the point once the angle is equal to the angle alpha. If this parallel plane passes through the vertex, obviously you get a straight line as the conic section. So a straight line is also a degenerate conic. And if the angle increases, or if the angle theta decreases, it's less than alpha, you get a section which looks like a pair of lines. So point, straight line and pair of lines. You can very clearly see if you have a plane which cuts the cone like this, which passes through the vertex, you can very clearly get a pair of lines, right? So straight line, pair of line and point are examples of degenerate conics. So I hope you understand what conic sections are. So in this topic, we try to analyze the equations of conic sections. That is, the equations of circles, straight lines, pair of lines, points, parabola, ellipse and hyperbola. And you understand the meaning of the words parabola and hyperbola. Ellipse comes when the plane is slanting, but it cuts both the edges of the cone. And parabola comes in a very special case where the plane is parallel to the edge of the cone. And hyperbola if the plane cuts both the naps of the cone. Now, as you can very clearly see, deriving equations from this definition of conic is difficult because this looks like a 3D problem where I don't know how to get the equations. So once you understand what conic sections are, to find the equations of conic sections, we have an analytical definition for these conic sections. So let us first look at the analytical definition of these conic sections.